In this video, we're going to examine the remainder theorem. So the remainder theorem states, if a number c is substituted for x in the polynomial f of x, then the result f of c is the remainder that would be obtained by dividing f of x by x minus c. That is, if f of x equals x minus c times the quotient plus the remainder, then f of c equals the remainder. So in other words, plugging this value into our polynomial function is the same as the remainder when we divide the function by x minus c. Let's take a look at an example. So in our example, we're given that f of x equals x to the fourth plus 2x cubed minus 5x squared plus x minus 25, and we want to use synthetic division to find f of 2. So again, the remainder theorem says that if we divide this polynomial by x minus 2, the remainder that we get will be the same as f of 2. So the remainder when we divide by x minus 2 is going to equal f of 2. So that's how we're going to find it, and we're going to use synthetic division to do so. So to use synthetic division, we're going to write down our coefficients. Notice that there are no missing terms. So the coefficient of x to the fourth is 1. The coefficient of x cubed is 2. The coefficient here is negative 5. For the x term is 1. And then our constant, negative 25. So I've written down all of the coefficients. And since I'm wanting to find f of 2, I'm going to write 2 out here. And then I'm going to complete our synthetic division process. So I'm going to drop down the 1. 2 times 1 is 2. That goes here. 2 plus 2 is 4. 2 times 4 is 8. That goes here. Negative 5 plus 8 is 3. 2 times 3 is 6. 1 plus 6 is 7. And 2 times 7 is 14. And negative 25 plus 14 is negative 11. So according to the remainder theorem, f of 2 should equal negative 11. Now we can verify this. So we can verify this by substituting 2 into the function just to see that we actually do get 11. So if I find f of 2 by substituting, then I'm going to have 2 to the fourth power plus 2 times 2 to the third power minus 5 times 2 squared plus 2 minus 25. Now 2 to the fourth power is 16. 2 cubed is 8 times 2 is 16 again. 2 squared is 4 times 5 is 20, and it's minus. And then we have plus 2 and minus 25. Well, 16 plus 16 is 32. So we have 32 minus 20 plus 2 minus 25. 32 minus 20 is 12. So we have 12 plus 2 minus 25. 12 plus 2 is 14. So we have 14 minus 25, and 14 minus 25 is negative 11. So we can see that the remainder that we get when we divide by x minus 2 gives us the function value. So this is an example that verifies the remainder theorem.